Welcome to Module 10, 4.2, more exponent rules in scientific notation. So this rule essentially, let me show you what it says. Essentially, if we have x cubed squared, like so we're raising something to a power that's being raised to a power. Well, we can think about this as a couple things. Anything squared is two of those. So this is really x cubed times x cubed, right? And then this is really 1, 2, 3. 1, 2, 3 x's. This is 1, 2, 3. So all told, if we have those three and these three, this is an x to the sixth. So if we have x cubed squared, we have x to the sixth. How do we use 3 and 2 to get 6? We multiply, and this is what this is saying. When we raise something to a power that's being raised to another power, we multiply those exponents. Okay, so that's that rule. Second rule, think about it. If we have xy to the third power, this is really xy, xy, xy. Group the x's together. X times x times x is x cubed. Y times y times y is y cubed. So really, if we are raising a product to a power, we can raise each piece of that product to the power. So ab to the n is a to the power of n and b to the power of n. Now, this rule down here essentially is the same thing. If we have x over y to the third, well, this is x over y times x over y times x over y. Multiply straight across. X times x times x is x cubed. Y times y times y is y cubed. So if we're raising a quotient to a power, we can raise the numerator and denominator to that power. And then the last one is part of that, but also with this negative exponent right there, we move things across the division bar. So notice the a ends up in the denominator, the b ends up in the numerator, and that's kind of consistent with the rules that we had from the previous section. So a couple more exponent rules that we're going to deal with. Now, the other thing that we're going to talk about here is scientific notation. Now, a number in scientific notation is of this form right here, m times 10 to the power of n, where m, this number here, is between 1 and 10, and this n is an integer, which is a whole number, positive or negative. So we can write numbers like 4.3 times 10 to the 17th power. You know, it's for writing really big numbers. This is a really big number. This is like 4,3 with a bunch of zeros after it. So this could be like the distance between the Earth and the Sun in terms of like miles or light years or something weird like that. So we're using this for talking about really big numbers. We can also talk about really small numbers, like we have 2.3 times 10 to the negative 34th power. Now this could be, the width of an atom in terms of millimeters or something like that, something that's very small. So we use scientific notation to denote very large numbers and very small numbers. I mean really big and really small. So the exponents tell us this positive exponent is going to give us a really big number. This negative exponent, we're going to be moving the decimal to the left. That gives us a really small number. Okay. So we're going to simplify these things using the exponent rules. So this right here, if we have t to the negative third raised to the negative sixth, this is following this rule right here. So if we're raising something to a power that's being raised to a power, we multiply these. So this is t to the negative 3 times negative 6. So that's going to be t to the 18th power. When we look at this, we have 4x cubed squared. So we want to think, what's being squared here? Now, the only thing that's being squared is this 3x squared because it's directly below the exponent 2 and to the left of it. So this 4 carries over. Now, if we're raising this to a power that's being raised to another power, this rule right here says we multiply. So that's going to be an x to the 6th power. Okay, so looking down at this next one right here. So if we look at this, we have a bunch of stuff raised to the third power. So we need to raise each of these things individually to the third power. As you can say, this is 2 to the third power, a squared to the third power, y to the negative fourth to the third power, and a z to the fifth to the third power. So we're raising each thing to the third power. So let's go ahead and do this. Now, 2 to the third power is 2 cubed, that's 8. A squared to the third power, because we're raising something to a power that's being raised to a power, we multiply. This gives us a to the 6th. Here, we're y to the negative 4th to the third. We're raising something to a power. being raised to a power, so we have a y to the negative 20th. And then finally, if we have z to the 5th raised to the third power, raising something to a power that's being raised to a power, so we have z to the 15th. And the only last thing we want to do is we want to make all our exponents positive, because we have this y to the negative 20th, we can move that down. And our final answer is 8 to the 6th, z to the 15th, all over a y to the 20th. And that's what we're looking at there. So, looking at this next one, same thing. We have the product of three things, x to the negative 4th, z to the 9th, y to the negative 2nd, all to the 4th. We raise each of these things individually to the 4th. So we have x to the negative 4th to the 4th, z to the 9th to the 4th, and y to the negative 2nd to the 4th. So, raising powers to powers, we multiply. So here we're going to multiply these. So you're going to have an x to the negative 16th, multiply z to the 36th, and then multiply y to the negative 8th. And then the last thing, of course, is we want to make all our exponents positive. So we got to bring the x down, x to the 16th, y to the 8th, and then rt to the 36th stays up top. And that's the answer to that one there. So continue. Oh boy. Okay. So continuing on with these rules of exponents, we got a couple more, and we're kind of using all of our rules in conjunction with one another. And then we'll move on to scientific notation. So here, a couple things. We have a negative 3. So one thing we can do is we can make this a positive 3. Now, when we make this a positive 3, what we really do is flip everything on the inside, because negatives move things across the division bar. So we can say this is a 3b to the 4th over 2a squared. Now we have a quotient, that is, we have a fraction in here, so we want to raise the numerator and denominator to the third power, but the numerator is composed of two things, the denominator is composed of two things, so we really want to raise just everything to the third power. So you have 3 to the third, b to the 4th to the third, and the denominator of a 2 to the third, and an a squared to the third. So then it's just a matter of simplifying these individual pieces right here. So we want to go ahead and cube this 3, which is 3 times 3 times 3. That's going to be a 27. b to the 4th cubed, raising something to a power that's being raised to a power. So we want to go ahead and say this is a b to the 12th. 2 to the 3rd is 8. A squared cubed is a to the 6th. And that is the answer that we're looking for right there. Okay? So one last one here. So we have a quotient again, so we're raising both the numerator and denominator to the third. So we have an m to the third over an n to the 4th to the third over a p to the third. So the only thing we really need to do here is our numerator is simplified. We have an m to the 3rd power. This right here, we're raising a power to a power, so that's an n to the 12th. And here we have a p to the 3rd. And that's simplified right there. So remember, we want to only have positive exponents in our final answers. We're using these rules of exponents to simplify these expressions. And as long as you use the rules, it doesn't matter what you use first or second or third, just as long as you use them right. All right, see you next time.